Dear students, welcome to Saimedha, Koti, Hyderabad. Now we are going to discuss the detailed solutions for TS Genco AE exam for the branch ECE, and the subjects what we are going to discuss are signals and systems and communication. So let us see the solutions. Now the sixth question in the ECE paper was given like this: the complex frequency S is equal to sigma plus j omega is the general case, then which of the following is correct? He gave 4 options. Now what happens if S tends to infinite? So he said that first option is S tends to infinite, then it becomes a sinusoidal, omega is equal to infinite means it becomes an exponential, and sigma is equal to 0 means DC. Various options were given. How to solve this problem? Look here. Here the complex frequency is given by S is equal to sigma plus j omega. Alright. This complex frequency term generally will encounter in Laplace transform. In Laplace transform, we must know one term called complex exponential. Complex exponential. Complex exponential is given by e power st. E power st. This complex exponential term will encounter in continuous time Fourier transform, Laplace transform, discrete time Fourier transform, and Z transform also. But in Laplace transform, complex exponential is of the form e power st. S is equal to sigma plus j omega na. So what happens if I substitute S value here? So my complex exponential becomes sigma plus j omega into t. Right. Now observe here. Here we will see what happens if sigma is 0, what happens if j omega is 0, what happens if omega is 0, and what happens if S is 0. See what happens if S is 0, if I substitute S to be 0 here in e power st, so it becomes a constant, right. So S tends to 0, so our complex exponential becomes a constant. Constant means DC, you can say, right. Now what happens if sigma is equal to 0? If sigma is equal to 0, what happens? Here we are going to have e power j omega t. E power j omega t. So cos omega t plus j sin omega t is nothing but a sinusoid. Okay, sinusoid. So sigma 0 means we will get a sinusoid. Sigma is equal to 0 means sinusoid. Basically e power j omega t is also known as complex exponential, as it is taking cos and sin. I have written sinusoid. Now what happens if omega is 0? Omega is 0 means this becomes e power sigma t. E power sigma t if sigma greater than 0. If sigma greater than 0 means this will be a growing exponential. If sigma less than 0, it will be a decaying exponential. Yes or no? Sigma greater than 0, you put growing exponential, sigma less than 0, decaying exponential. So if omega is equal to 0, we are going to have an exponential sigma. Exponential. Now we must select for this option. Third option, if you observe, S is equal to 0, constant DC, omega is equal to 0, exponential, and sigma is equal to 0, sinusoidal. Yes, option 3 is your answer. Option 3 is the answer. Hope you understood this problem. Right. After this, let us look at the next question. This is the next question. Question number 7. And here he said, for the equation x double dot of t, means double time differentiation, is nothing but d square x of t by dt square plus 3x dot of t plus 2x of t is equal to 5. The solution x of t approaches which of the following values as t tends to infinite? Means he is asking us to find out the final value. T tends to infinite means he is asking us to find out the final value. Now what is the differential equation? the differential equation is x double dot of t means d square x of t by dt square plus 3 times dx of t by dt plus 2 times x of t is equal to 5, right. Now, after getting x of t from this differential equation, right, now you have to find out the final value. How to find out? Look here, applying Laplace transform, here what is the Laplace transform for d square x of t by dt square? S square into x of s plus 3 times of dx of t by dt. What is the Laplace transform? S into x of s plus 2 times of x of t. So, 2 times of x of s. Here 5 is there. 5 means here whenever you are having constant like this, you have to consider the unilateral Laplace transform. Suppose if I consider the bilateral Laplace transform means limits in the integration of Laplace transform definition exists from minus infinite to plus infinite, right, and bilateral Laplace transform of this type of constants does not exist, but unilateral Laplace transform exists. Unilateral Laplace transform means it is taking the form of phi u of t. So, phi by s. Okay. Now, taking x of s common, s square plus 3s plus 2 is equal to phi by s, or if I separate, or if I try to get x of s, this is phi by, I can write this as s into s plus 1 into s plus 2, right, fine. Now, final value we have to apply. See, always remember, whenever you are going to apply final value theorem, there are some restrictions to be observed. They are, see, final value theorem is applied if and only if all the poles in this expression must lie on the left half of s plane, including a simple pole at s is equal to 0. So, one pole at s is equal to 0 is allowed, and remaining poles must lie on the left half of s plane. Yes, they are lying. So, we can happily apply final value theorem. And what is the expression for final value theorem? X of infinite is equal to limit s tends to 0 s times x of s, or this is limit s tends to 0 s times x of s means phi by s into s plus 1 into s plus 2. So, s gets cancelled. What happens if I substitute s is equal to 0? This is phi by 2. So, this is the final value. Now, we have to search for this option. So, phi by 2, option 2 is your answer. Option 2 is the answer. Hope you understood this question, right? Now, let us look at the next question. Yeah. Y of n is equal to x of n minus 2 x of n minus 1 plus x of n plus 2 is a good approximation to. He gave the 4 options. I mean, high pass filter, band pass filter passing this frequencies, low pass filter, band stop filter, he said, right. So, first of all, let us write the difference equation. See, this kind of equations are known as difference equations. X of n minus 2 x of n minus 1 plus x of n minus 2, right. Now, how to determine the type of filter? See, in discrete case there are number of ways to find out the type of filter, but here let us see the Z transform. From the Z transform you do one thing, try to get the transfer function h of z. From this transfer function you can get the low frequency gain and mid frequency gain, high frequency gain, and with comparison you can say what type of filter is a given difference equation, right. Now, applying Z transform, what happens? Here y of z is equal to x of n, Z transform is x of z minus 2 times x of n minus 1, use your shifting property, z power minus 1 into x of z plus x of n minus 2 z power minus 2 into x of z, or y of z is equal to, take x of z common, 1 minus 2z inverse plus z power minus 2. Now I will take the ratio y of z by x of z, which is nothing but h of z. H of z, which is 1 minus 2z inverse plus z power minus 2. This is your transfer function. Transfer function I got. Now from this transfer function, if I want the low frequency gain means it is given by modulus of h of z, magnitude of h of z at z is equal to 1. Z is equal to 1. So z is equal to 1, if I substitute, what will happen? So it is 1 minus 2 plus 1, no? Right? So it is simply 0. Low frequency gain is 0. Now let us find out the high frequency gain. Z is equal to minus 1. Z is equal to minus 1 means here what will happen? 1 plus 2 plus 1, which is nothing but 4. So here low frequency gain is 0, high frequency gain is 4, means higher frequencies are having more gain than lower frequency. So definitely this must be a high pass filter. And see, if high frequency gain also resulted in 0, I would have calculated mid frequency gain, because it could be band pass filter or band stop filter. For band pass filter or band stop filter, low frequency gain and high frequency gain will be 0, but here high frequency gain is not 0, means definitely this becomes a high pass filter. So high pass filter means option 1 becomes the correct answer. Hope you understood this question, right? After this, let us look at the next question, right? So in this question, he is saying that, ninth question, the unilateral Z transform is restricted only to the analysis of. First of all, unilateral Laplace transform, or it is also known as one-sided Z transform. One-sided Z transform is given by x plus of z. X plus of z is nothing but summation n varying from 0 to infinite x of n into z power minus n. This is the expression for unilateral Z transform. As we are having unilateral Laplace transform, in Z transform we are having unilateral Z transform. Suppose if I take the limits of summation to be, if I take or consider the limits of summation to be minus infinite to plus infinite, it is known as bilateral Z transform. Bilateral means limits of summation are considered from minus infinite to plus infinite, whereas unilateral Z transform means, or one-sided Z transform, limits of summation are considered from 0 to infinite. And remember, the purpose of unilateral Z transform, is, it is used to analyze causal LTI systems. What is the purpose? Unilateral Z transform is used to analyze causal LTI systems by solving difference equations, with non-zero initial conditions, This is the purpose. So unilateral Z transform is used to analyze causal LTI systems by solving difference equations with non-zero initial conditions. That is the reason we are going to have a different time shifting property for unilateral Z transform. So if you observe, causal systems with causal inputs, causal system with non-causal inputs, right? So appropriate answer is causal systems. It is used to analyze causal systems with causal inputs. Option 3 is the correct answer. Hope you understood this. This is the next question. He said match the following. So on the left side he gave the properties of systems, and on the right side he gave the input output relationship, right. First of all, linear he said. So in the right side, which input output relationships are linear? So this is linear. Y of n is equal to x of n square is linear. How to check linearity of a system? First of all, apply x1 of n so that you get y1 of n. Second, apply x2 of n so that you get y2 of n. In the third step, apply linear combination of inputs ax1 of n plus bx2 of n. As a result, if you are going to get ay1 of n plus by2 of n, your system is linear, otherwise non-linear. So this is linear. This is linear. How can I say? Y of n is equal to x of n square. So first case, apply x1 of n, means this becomes x1 of n square. Second step, apply x2 of n, so that this becomes x2 of n square. In the third step, in the place of x of n, apply ax1 of n plus bx2 of n. So ax1 of n square plus b ax1 of n square plus b x2 of n square. So this is ay1 of n plus by2 of n. So y3 of n is ay1 of n plus by2 of n, means it is linear. But here what happened, this one is also linear. Y of n is equal to x of minus n is also linear. Okay, so you can apply the linearity, you will get this one also to be linear, and here this one is also linear. This one is also, first one is also linear, but here ambiguity is there in this question. So A4 he said, A2 no, x square of n is non-linear, A4 and A1. So here ambiguity is there. So we will do one thing, let us map A to 4, okay. And non-linear means here this one is linear, this one is linear, this one is linear. Non-linear is x square of n. So A4, B2, C. Causal he is asking. Causal means output at any time instant must depend on present and past values of input, but not on future. So I think he means to, his assumption is already we have taken these two, na. So among the remaining we have to answer. Among the remaining means, okay, among the remaining means here basically this input output relationship, first one must be given like this. Minus infinite to n x of k, this must be given like this, but he has given minus infinite to infinite. I think there is a mistake here. So you can map, see causal means, I think he means to, this might be n, you can map C to 1, and obviously D is non-causal. Again non-causal means the fourth one is also non-causal, but the fourth one is taken by linear, right? So third one is non-causal. So y of n is equal to x of minus n. What happens if I calculate the output at minus 2? This is x of 2. For minus 2 is future value, non-causal. And if I take the fourth one, y of n is equal to x of n square. What is y of 2? It is x of 4. For 2, 4 is future value, non-causal. So, but here for every property, two options are there, but yes, you can select this one as the answer. There is some ambiguity in this problem. So A4, B2, C1, A4, B2, C1, D3. You can select option 1 as the answer. Hope you understood this problem.